Welcome back, guys. So this is question 6.24 of chapter 6, and the statement of this question is: a coin is tossed 400 times. Use the normal curve approximation to find the probability of obtaining A between 185 and 210 heads. Okay, so let me write the data with it as well. So the given data is, we want to find the probability that X is in between 185 and 210 heads, where X is the number of heads. So here X is greater or equal to 185 and less than or equal to 210. Okay, this is part A. Okay, also we are given that a coin is tossed 400 times, so therefore the total number of tosses are 400 and equal to 400. Okay, in B we have to find out that exactly 205 heads are obtained, so P is X equal to 205. okay, and C is fewer than 176 or more than 227 heads. Okay, means the probability that X is less than 176 and greater than 227. Okay, so these are the three unknown parts we have to solve for them. Okay, and it is clear that for it we have to use the probability table, but for that we have to find out the values of Z. So here, to find the values of Z, we know that Z is equal to X minus mu divided by sigma, where mu is the mean value and sigma is here given, which is the standard deviation. So now the value of mu for the normal distribution, as the probability given is the normal distribution, so the value of mu is for it NP, and the value of sigma square or variance is what? That is NPQ, while the value of the standard deviation is the square root of it, so therefore it would be NPQ. Okay, what is Q? Q is 1 minus P, so let me write it here as well, that is 1 minus P. Okay, so all of these values are given. The value of P is 1 by 2 because this is the coin toss example, so the value of P is 1 by 2, and the value of Q is therefore 1 minus P, that is again 1 by 2. Okay, so let me put all these values here, and in solving it, N is 400, the value of P is 1 by 2, so that is therefore 200. The value of NPQ is, that is 400 multiplied by 1 by 2 multiplied by 1 by 2, so that is 100, and the value of standard deviation, which is the square root of 100, that is 10. Okay, so all of these values are known. So let me use this formula to find out the values for each of the X here. If I call it X1 and this one X2, okay, so here we will have what? Here we will have, in part A, we will have the probability that this capital X is greater than X1 and less than or equal to X2. We will have to convert it into the probability that X is greater or equal to Z1 and less than or equal to Z2. Okay, so to find out the values of these, let me use this color. So the value of Z1 is X1 minus mu divided by sigma, so it would be, the value of X1 is what? The value of X1 is 185, so 185 minus mu is 200, that is 200 divided by what? Sigma, that is 10. Okay, so here it would be 15 minus 15 divided by 10, so it would be 1 minus 5. Okay, similarly the value of the Z2 is what? That is X2 minus mu divided by sigma. So putting values here, the value of X2 is 210, 210 minus mu is 200 divided by what? Divided by 10. Okay, so it would be what? It would be 10 divided by 10 is 1.0. Okay, so the values of z1 and z2 are known. Okay, the value of z2 is here while the value of z1 is here. Okay, let me move down somehow. Solving it, we will get the probability that z is greater or equal to minus 1.5 and less than or equal to 1.0. So we have to find in the z distribution table where phi and z is 1.0 minus in the z distribution table we have to find it minus 1.5. This is the CDF table. So let me move to that table. So this is the table. First we have to find 1.0. So where is the 1.0? So the 1.0 is here. That is 0.8413. So 0.8413 minus, so 0.1486. Okay, let me calculate it from this one. So it would be 0.8413 minus 0.1486. So it is 0.6927. Okay, so the answer of it is 0.6927, and this is the approximate solution of the part A of our question. Okay, so that is basically the solution when we will keep it greater or equal to the z1, but we have to keep it in our mind that this is not the discrete distribution, but that one is basically the distribution where it must be greater than this one. So if I want to make it greater than this, so it should be then 184.5 minus 200, because only in this case, if you can also make it 0.9 as well, but keeping 8.5 will give me the average value of it and divide it over 10. Okay, so keeping and doing all of these things, we will get here 1.05. Okay, similarly here we will have to make this one as 210. So if I want to make this x less than this one, so this would be 209.5 minus 200 divided by 10, and that would be here something different. Okay, so you can also keep those values here as well, and in that case it would be the value of z is greater than minus 1.55 and it will be less than 1.05, and then we have to find the values here. 1.05 minus this minus 1.55. Okay, so when you will find out these values, so those values would be 0.8531 minus the value of it would be minus 1.55. It would be what? Minus 1.55. Okay, so this would be 0.0605. 0.0605. Okay, calculating it, 0.8531 minus 0.0605. So this is 0.7927. 0.7927. Okay, so that is basically the solution of our question. In previous solution, which was here, what we had found out and what which were given was due to all this greater or equal to. Okay, now we have found out what all of this is on the basis of this greater than sign, and you can see that the answer or the actual answer is this one, because all the z distribution is based on now this one. In our upcoming video, we will try to solve the remaining parts of our question. Till then, absorb all the steps which we have carried out in this video. Till then, take care of yourself, and I will see you with the other parts of these questions in our upcoming video. See you soon.